Okay, so we're going to pay close attention so I don't lose you. Okay, when we did factorial notation, we said it was just the number itself all the way down to 1, right? So like 6 times 5 times 4 times 3 times 2 times 1 would be 6 factorial, correct? What we're going to deal with today is not a number factorial, we're going to deal with a letter factorial. So if we had n factorial, it would be n times n minus 1 times n minus 2 times n minus 3 onwards, right? Because we're just going down by 1 each time. Okay, and then you would go till you hit 1. Well, depending on what n is, would be how long you would keep going, right? Because if n was 4, you'd have 4, and then n minus 1 would be 3, then n minus 2 would be 2, then n minus 3 would be 1, and then you'd be done. So it depends on what n is. We don't know. We just leave it as n's. Now, the reason why that's important is over here is your big old formula sheet. So if you ever ask, do we get it on the formula sheet? This is your formula sheet. I'm going to hand you one out after. These are the formulas you're given. This whole side is trig, and then this is the other units. Okay? I know, exciting, right? Trig is 3 units. Chapters 4, 5, and 6 in your textbook are trig. This is all trig. So binomial, theorem, permutations, and combinations, this is the unit we're on. It gets this little piece here. Now, if you look here, it tells you n factorial to n times n minus 1 times n minus 2 all the way to 3 times 2 times 1. Right? So it actually gives you that info. The reason why this is important is if they ask us to solve it using the formulas, the NPR formulas and NCR, this is if it's a permutation and this is if it's a combination. Our calculator will do NPR for us. But if they ask us to solve for a piece like N and R, depending on what they give us, which we'll go through today, then we're going to use these formulas. Okay? And that's why we need to know how the heck this N factorial formula works in order to be able to do these other two formulas. So we're going to simplify the following expressions. Leave your answers in product form. That means don't FOIL them together. There's no point. Okay? So if you have n plus 2 and n plus 1, n, you're just leave them like that. You're not going to FOIL them all together. Okay? So do not expand them. The way we want to simplify this is we want to figure out which ones are common so that we can cross off commonalities. Okay? So we have to figure out which one is bigger than the other one, and then expand the bigger one. And you'll see what I mean. So, n plus 2 and n, which one is actually bigger? N plus 2. Because n plus 2 you can keep expanding until you get to n. You're just falling apart. I think your quiz is underneath your feet. Okay. All right. Okay, so the n plus 2 we can expand to get to n factorial. So that's when we're going to expand first. So n plus 2 factorial expanded is n plus 2. 1 less than n plus 2 is n plus 1. 1 less than n plus 1 is n. And then 1 less than that would be n minus 1. Right? And then we can put a factorial symbol behind it. Why can we do that? Because it's still going on, right? It just keeps going on forever. Now the bottom, it would be n factorial. What's 1 less than n? N minus 1 factorial. And what are we seeing here? I could keep going n minus 2, n minus 3, n minus 4. I could keep going on for life if I really wanted to. But there's no point because now I'm starting to see overlap, correct? And now I can cancel off. So the n and the n and the n minus 1 factorial and n minus 1 factorial. Would I have even had to expand the bottom? Could I have just stopped the top at n factorial and the bottom would be n factorial and canceled them? Absolutely. I just wanted to go a little further so you could see what the heck we're doing. Okay? So ultimately our answer in the end is just n plus 2 times n plus 1. Okay? B, which one is bigger? N minus 1 factorial or n minus 2 factorial? N minus 1. N plus 2 is bigger, but n minus 1 is bigger because then you do one less, that gets you to n minus 2, right? So we're going to expand the bottom. So on the bottom, it's going to equal n minus 1. 1 less than that is n minus 2 factorial. Now why would I stop there? Because there's an n minus 2 in the numerator in the top. So they're going to cancel. If you want to keep going, you could. Now these cancel. When something cancels out, those little slashes are actually like diagonal ones, correct? This is just a 1. You were taught that in elementary school. When anything cancels off, it's just left as a 1, right? So on the top, it doesn't just go away and evaporate. The numerator is still there, but what's in the numerator? A 1. And then in the denominator, you have n minus 1 times 1, which is just n minus 1. Yeah? See? We can only expand the top. The bottom doesn't have a factorial symbol. So I'm going to expand the top because it's the only thing I can do. So in the numerator, I'm going to get n, and then what next? N minus 1. Now, can I just leave a factorial symbol here and then cross off the tops and the bottoms and just have a random factorial symbol floating on the top? No. The factorial symbol has to be behind something, correct? It can't just be floating there. It means the factorial symbol only means something if it's behind something. It means that number to 1. Yeah? So I have to expand one more. And then on the bottom, I have n minus 1. These cancel, and they become 1s. Now, if I have a 1 left in the numerator, like I did in the last one, I have to keep the 1, correct? But if the whole thing is over 1, do I have to keep the 1? No. Every number has a denominator. So if you have like 4 or 3 or 2, those are just 4 over 1, 3 over 1, 2 over 1. We just don't write the 1s, correct? So same thing here. N minus 2 factorial. Okay? So those are helping us to actually get to example 2 and be able to solve example 2. Not so much that we're going to actually be asked to do anything like example 1, but we need to know that math in order to do example 2. Now, example 2, this here is actually the Npr formula. The Npr formula is n factorial over n minus r factorial, correct? This one is n factorial over n minus 2 factorial. So we know r is 2. We just don't know what the heck n is, right? So this would be another way they'd ask us to, they could ask this question like this. NP2 equals 42. Solve for n. It's the exact same question, except example 2 is written nicer because they've already put it into the equation for you. Okay? So we need to solve. Whenever we hear the word solve in any unit in math, it means the exact same thing. It's great because it doesn't change. It means tell me whatever the heck the variable equals. There's a variable. I want to know what it equals. That's it. So if it says solve, in the end, I need to have variable equals number. No matter if I'm in logs, exponential, if I'm in transformations and I'm doing some solving, not trig. It doesn't matter what unit I'm in. If it says solve, I want variable equals number. That's it. It's not tricky. It's not different. That is always what it means. Okay? So we're going to try and figure out what the heck n is. So did I have to say solve for n? No, I could just say solve, and that means for n. Okay? So n factorial over n minus 2 factorial, which one's bigger? N factorial. We're going to expand it to try and get rid of the other one. So we always expand the bigger one. So we're going to get n, 1 less, n minus 1, 1 less, n minus 2. Do I keep going? No, I can just put a factorial symbol behind that. And then the bottom will cancel off with it, right? And it equals 42. And then grade 11 comes flying back at us at a very fast pace. Okay? So we're left with n times n minus 1 equals 42. This is grade 11. This is solving quadratics in grade 11. So if I expand those in, because I'm going to now. I just didn't expand up here because I didn't have to solve anything. I'm going to put that n in. I'm going to distribute it in. N times n is n squared. N times 1 is minus 1n, and it equals 42. Now, grade 10 was a lot easier because grade 10 never had a quadratic. Grade 10 had linear. It was always 3x plus 7 equaled 2, and you'd solve for just the x by isolating it by itself, correct? But then grade 11 came along, and you did quadratics. What's the rule in order to solve quadratics? You can't isolate the variable because there's two of them. Well, there's one variable, but one's squared and one's not squared. Yeah? So you can't isolate it like you did linears. So you always had to move everything to one side and get it equal to 0, and then you could factor a quadratic formula. Those were your two things that got drilled down your throat last in grade 11. You need to do this, you need to do this, you need to do this. So if it's linear, you solve for the variable, you're golden. If it's a quadratic, you have to move everything to one side, set it equal to 0. That's the very first step instantly. It should be just part of your brain. It'll come back if it's not. So we're going to move that 42 over. N squared minus n minus 42 equals 0. Now, if you can factor, I would, because quadratic formula is not fun. Great thing about your formula sheet is at the very top left, they give it to you. Now, if you look at the very top left, look at the equation above it. It says 4 ax squared plus bx plus c equals 0. What do they have it equal to? 0. You always have to, even for the quadratic formula. So up there, they even tell you what form you need to have it in order to put it into that equation. They're that nice. Okay? So, factoring. What times what equals 1 times negative 42? So A times C. This one times this one. What plus what equals negative 1? If you're someone who factoring was not your strong suit, I should see you in at lunch hour so it is your strong suit, because you're going to need to be able to do it like that without thinking. Okay? So what multiplies to give you negative 42 and adds to give you negative 1? Negative 7 and 6? I don't even have to do decomp because I have a 1 in front of my n squared. The moment I have a 1 in front of my n squared, I can just go straight to brackets. N minus 7, n plus 6. And then there was one more step in grade 11. Because have I solved? Do I have n equals anything right now? No, I have two factors, but I don't have n equals anything. So I take those two factors. N minus 7 equals 0. N plus 6 equals 0. N equals 7. Move it over. N equals negative 6. Okay? Now, both of these seem reasonable to you because you have absolutely no idea what the heck n needs to be. But the negative actually isn't reasonable. And the reason why is this is a permutation, okay? If there's a p, permutation order matters. You don't know any of that yet because we're going to go through it, but we go through how to do this first. The n stands for the total number of them. So say we were arranging 2 books out of 7. Okay, say we had 7 books, and we were arranging 2 of them. Okay, we would go 7p2, or we'd have 2 blanks, and we go 7 times 6, correct? Yeah, it's the same thing. The catch is this n needs to be bigger than this, because I have 7 books, let's say, and I pick 2. Could I have 1 book and pick 2? Does that make any sense? No. Could I have negative 6 books and pick 2? No. Could I have 7 and pick 2? Yes. So which one of these is reasonable? 7. You can also check it. So in your calculator, there's a button. I'm going to show you how to do it. Okay? It's in that same spot as the factorial symbol, except it's 2 buttons up. So we want to see if this is true. We say that n is 7, right? Ultimately, that's what we said. So if we type 7p2 into our calculator, we should get 42. Should we not? So let's see how to do it. Turn on our calculator. So I'm going to go 7. Then I go to where my factorial symbol is. So math, left to probability once if you have these calculators, twice if you have the fancy ones, and 2. C is a different one, so I'm going to pick 2. And what am I going to put now? Npr 7p 2, enter. 42. So I know I'm right. Okay? It's a tricky button. It's right beside the 1. Okay, we're going to flip over to the next page. So that was leading us into these next pages. So the next page says permutations of n different elements taken r at a time. So in here it says that r has to be less than or equal to n. Or we could say that n has to be greater than or equal to r. Because you can't choose a number from something that's smaller than it, right? Like you can't go 1 permutation 2. That means you have 1 and you pick 2. That doesn't make any sense. Can you do 2 books and pick 2? Is that fine? Yes, they can be the same number, but n has to be at least the same number or greater. Or r has to be at least the same number or less. Okay? So calculate AP3, we're going to use the formula first. So the formula is this. So wherever there's an n, I'm going to put an 8. Wherever there's an r, I'm going to put a 3. Yeah? Is it equal to anything right now? No, it will be. That's what we're trying to figure out. So we're going to have 8 factorial. So 8p3 equals 8 factorial over 8 minus 3 factorial. Which is 8 factorial over 5 factorial. And we could actually expand this out if we wanted to try and do the math on our calculator. 8 is the bigger factorial, correct? So we can make 8 become 5. So we could go 8 times 7 times 6 times 5 factorial over 5 factorial. And then our answer would just be 8 times 7 times 6. Could you just go 8 factorial divided by 5 factorial, get the same answer? Yeah. What's 8 times 7 times 6? Pardon? 336. Now we're going to use our calculator and see. 8p3. Punch it in. 8, math, over to probability. 3. Did you get 336? The next statement is bolded, capitalized, and question marked because that is exactly what's going through your head right now. Why do we need to use this formula if we can just use our calculator? Extremely large yelling in your head with a whole bunch of question marks, right? Great question, guys. Here's why. How do we do that one? Right? If it's 8p3, I expect you to go 8p3. I expect that. But they can give you ones like this. And it's not as easy, right? Could you guess and check and somehow like go 8p2, 7p2, 6p2, and then 8 would be n minus 1. Okay, then it's one more and figure it out that way? Sure. Often people will go the wrong direction and get it wrong. But you could. But we're going to go through it with the formula. So this goes in where n is. This goes in where r is. And we set it equal to this. And then we're going to solve for n. So our formula is n factorial. So n minus 1 factorial over n minus r factorial. So n minus r factorial. Where do you see there being an issue here? Hint, the 2 is a monomial, one term, so it's not an issue. So n minus 1 minus 2. What do you think you have to remember if the r is not a monomial? if the r is more than one term. Right now we go minus 2. We're going to need brackets. Or you're going to have to at least remember that you're subtracting everything behind it. So if this happened, if this was instead n minus 2, then I would have brackets minus n minus 2, which would actually be minus n plus 2. Okay? So if your r is a binomial or more than one term, you have to remember to distribute that minus sign in. Whenever there's a subtraction sign, if anything follows behind that's not just one term, if it's a binomial or a trinomial, so 2 terms or 3 terms, you have to remember to distribute that subtraction sign in. Throughout the whole entire year, you have to remember that. Okay? And then it equals 90. So now I have n minus 1 factorial over n minus 3 factorial equals 90. Okay, which one's bigger? N minus 1 or n minus 3? N minus 1. We always expand the bigger one because it can become the smaller one. So, n minus 1, n minus 2, n minus 3 factorial over n minus 3 factorial equals 90. These cancel. And I'm left with n minus 1 times n minus 2 equals 90. What do I need to do next? Distribute? Yeah. Need to FOIL it. So n squared minus 2n minus 1n plus 2 equals 90. Holy smokerdoodles, Batman, I have a squared. What do I need to do when I have a squared? Part of your brain should just come out. Move it all to one side, set it equal to 0. You combined were a really good answer. Okay, so teamwork. N squared minus 3n, subtract your 90 over, minus 88 equals 0. You try and factor it, see if your factoring can come back to your head. Negative 88. What times what equals negative 88? What plus what equals negative 3? Negative 11, positive 8. Because there's a 1 in front, I don't have to do decomp. So I get n minus 11, n plus 8. N minus 11 equals 0. N plus 8 equals 0. N equals 11. N equals negative 8. Negative 8 makes absolutely no sense. So it's 11. Can we try it out? Sure. Plug 11 in for n. 11 minus 1 is 10. 10p2 is 90. You know you're right. Okay? Obviously, life doesn't say that good. So, I want you guys to try number 2, A, and C for now. And then we're going to maybe try B and D. But you try these 2. Okay, this first one up here, n plus 1 and n. N plus 1's bigger. I'll get n plus 1, n factorial over n factorial equals 6. Let's cancel. N plus 1 equals 6. N equals 5. Then you can check it. So you can go 5 plus 1 factorial over 5 factorial equals 6. 6 factorial divided by 5 factorial is 6. Because 6 times 5 factorial. That's how you prove it algebraically. But you would just type in your calculator and equal 6 and you'd be golden. Right? C, n plus 2 is bigger. n plus 2, n plus 1, n factorial equals 12. FOIL it out. So distribute n squared plus n plus 2n plus 2 equals 12. I have a squared. That means I have to move everything to one side, get it equal to 0 every time. Just like grade 11 all over again for like 2 months. Actually, ever since you learned quadratics, you had to do it for the rest of the year. Okay, n squared plus 3n minus 10 equals 0. What multiplies to give me negative 10 and adds to give me 3? Positive crap. I mean, oops. Whatever. Positive 5, negative 2. So n plus 5, n minus 2. If you get your symbols wrong, you're going to get your answer backwards, and then they're going to have that answer on the test, right? So we don't want to get our symbols wrong. So n equals negative 5, n equals 2, n can't equal negative 5. If you checked it, it would say error in your calculator. Okay? B and D are a little bit harder, but B is literally one step away from A and C. What could you do to get it to look like A and C? Divide that n minus 1 factorial over so it's equal to 6. Because you need them together in order to get something to go away. Okay? And this one, I would divide the n minus 1 over 2. So I would get n plus 1 factorial over n minus 2 factorial. And joining it would be n minus 1. But does it have a factorial symbol behind it? No, so you don't give it one. Equals 20. Try those two out with the change I made. Okay. So the stuff we're going to deal with today are words, but they still don't have repetitions, which makes a difference. Like kitchen as opposed to pool. Pool would have 2 O's, right? The stuff we're dealing with today, every letter is different, which makes it easier. So find the number of the permutations of the letters in the word kitchen. Kitchen is how many letters? 7. Are there any doubling letters? No. If the letters K, C, N must be together, but not necessarily in that order. So this is where the be together thing starts. So paying close attention. So we are going to use up the whole word. 1, 2, 3, 4, 5, 6, 7. But K, C, N must be together. But it doesn't have to be in the order K, C, N. Okay? So the way we do this every single time, pay close attention and it'll be easy for you, is we always lump them together first. Okay? So we're putting K, C, N together. I'm going to put them together here. I'm going to hook them together so that forever they'll be stuck together because they have to remain together no matter what. Right? Now, those blanks can hold K, C, or N. Correct? It could be K, C, N. It could be C, K, N. It could be N, C, K. It could be N, K, C. Right? Any order. Coming up with all the different orders would be painful. So the best way to do it is just write it like we did before. So I could have K, C, or N here, which is how many options? 3. But because it's a word, we don't repeat. So I'm going to keep an N. Then I have a K or a C here, 2. Keep the C here. Then I have a K, which is 1. We agree? Does it matter what the last letters are? No, but how many do we have left? 4. So we have 4 left for this blank, then 3, then. And you would be done if it said K, C, N are together at the front. Does it say that? No. They can be together. So let's think about it this way. These are my 4 letters I have left, right? The 4, 3, 2, 1 at the end. These are the 4 letters that are not K, C, N. And we'll pretend this is K, C, N lumped together as 1. Okay? So it's here at the front, correct? Could I move it between these 2 letters? Would they still be together? Would the word be totally different? Yes. Could I move it between these 2 letters? Would they still be together? Word totally different? What about here? Or at the back? So we have to count those ways. So this is one way, where it is right now, correct? Then I could move them between these two letters. Some people say, well, I can move it here. No, it is there. It's in front of that letter. So moving it there would be like, it's no good. Okay, so this is 1. Then this would be 2. Then this would be 3. Then this would be 4. Then this would be 5. It's always one more than this number. Of course, right? Because this is 1, 2, 3, 4, and then I have 1 up here. So it's always one more than this blank. So you have to multiply it by 5. Why do you multiply it by 5? Because you get those exact same numbers, but in 5 different cases. Let me show you. So instead of writing out 5 cases of the same numbers, we're just being lazy, actually, or brilliant, whichever way you want to think about it, and not writing out all the 5 cases. So we could have, oh, disappointing. That marker wasn't working. Okay, so we could have our 3, 2, 1, 4, 3, 2, 1, right? We could have our 3, 2, 1, 4, 3, 2, 1. We could have 4, 3, put the 3, 2, 1 between them, 2, 1. You go 4, 3, 2, 3, 2, 1, 1, 4, 3, 2, 1, and put the 3, 2, 1 at the back, right? When you multiply those all out, how many of them are there? 5 that are exactly the same. Or I could do this and add up them up 5 times, which would not be fun, right? So that's why we multiply by 5 at the back, and it's always one more than that. Make sense? I can actually write this out now as 3 factorial times 5 factorial. Why? The 3 to 1 at the beginning is 3 factorial. And then the 5, 4, 3, 2, 1 is 5 factorial. Now, you could go 3 factorial, 5 factorial, and give me an answer too, right? And it would work. Or you could go 3 times 2 times 1 times 4 times 3 times 2 times 1 times 5, get an answer, match it to their multiple choice answer, and golden. Okay? But sometimes they don't turn it into answers. They literally just write it like that. Now here it says number of permutations arrangements where order matters of the letters in the word kitchen if the vowels must not be together. Okay. This is the big one at the end where you have to visualize this. Okay. So if there are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17 people here today. Okay? Tiny, tiny class. This is fantastic. Normally they're like 31. You're like half of a normal class. One person's missing. Yeah. So there's 17 people in this class. Now, if I asked you how many people in this school are not in this class, would the fastest way to be like, okay, just everyone sit, no one is allowed to pee. You all stay in your rooms. I don't care. You hold it if you have to. And then you go to Baldwin's room and you start counting. And then you move over to lines and you're like, bah, 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 and you hope no one's outside playing in the snow. You miss someone or someone's missing and you count them all. Is that the most efficient way to do it? No, that's actually terrible. There's probably some sick people. There's not even one person in our class right here. So that's bad. That's a bad way to do it. Now, if I say, how many ways can you do kitchen if the vowels are not together? If you start trying to draw all the ways that the vowels are not together, is that going to be the most efficient way? No, it's going to be terrible, just like if you went around and counted the people in the school in other classes. What's the fastest way for you to tell me how many people are in this school but are not in this class? Go to Mrs. O, be like, how many people are in this school? And then be like, how many people are in this class? And you're correct. So the fastest way actually to tell how many words you make where the vowels are not together is to actually find out how many ways can we rearrange kitchen with no restrictions. That's like how many people are in this school, right? How many ways can we do kitchen, no restrictions? So kitchen, no restrictions. And then we're going to minus off what? With restrictions, but what restrictions? Vowels together. Because if we take the total, no restrictions, and we subtract off all the words where the vowels are together, what's left over? Not together. Rather than going around and counting every kid in this school, we are taking the total and we're subtracting the kids in this class, and boom, we have how many people are not in here, correct? So when it says not, what you actually do is you take the total, no restrictions, subtract off them together, and then how many are left over? All the ones that the vowels are not together. Okay? So we minus vowels together. Okay? Kitchen no restrictions, super easy. How many letters are there? How many blanks are there? And we go 7, 6, 5, 4, 3, 2, 1, which is what? Which is also known as 7 factorial. 7 factorial or 5040. We agree? Because it's just 7 blanks. You leave one, you leave one, you leave one. So 7, 6, 5, 4, 3, 2, 1. Another way to look at it is like this. We agree? Okay. Now we subtract off the vowels together. It's just like this, but just vowels together. How many vowels are in kitchen? 2, the I and the E. And then what do? You look again and make sure you only have 2. Because it sucks when you miss one. Okay, so there are 2. We want to keep them together. 1, 2, 3, 4, 5, 6, 7. There's 2 that are together. I'm going to lump them together. Now, how many vowel options do I have for this blank? 2. Then this one. Then how many letters left? 4, 3, 2, 1. Blast off. Okay. Now, are we done that one? Is that all the ways that the vowels can be together? No, that's all the ways the vowels can be together at the front. So we have to multiply it by 6, because it's always one more than this, because this is one way. 2, 3, 4, 5, 6. So we put a 6. So it's going to be technically 5040 minus 1440. Which is for 3,600. Don't ask me to write a paragraph, but I can do math. Yay. Don't even know what's an onomatopoeia, iotomatopoeia, nominatopoeia, and yamanabatopoeia. I don't even, iotomatopoeia? Onomatopoeia? How do you say it? Onomatopoeia? Onomatopoeia. I know what it is. It's like, but I don't know how to say the word. Onomatopoeia? And onomatopoeia. Onomatopoeia. Get myself some pizza. Okay. 3,600. Good times. I'm going to ask you to do one question out of your